All right, if you're a senior engineer, you already know this for a fact. Building software that actually solves real business problems is incredibly hard. So today, before we even think about touching architecture or writing a single line of code, we're going to make a massive mental shift. We need to completely rethink what a model actually is.
Okay, here is a slightly opinionated core truth that you really need to internalize. A domain model is absolutely not the real world, not even close. It is simply the version of the real world your software actually needs to care about. As technical people, we fall into this trap all the time. We want to capture every single attribute, every possible edge case, the entire physical reality of a business process. But domain-driven design, it argues the exact opposite. Modeling isn't about making some hyper-realistic copy. It's actually a highly selective process.
We've all done it, right? We assume a domain model is a UML diagram, or a database schema, or an entity relationship map, but it really isn't. A diagram might help communicate a model, sure, but it's not the model itself. And it certainly isn't a perfect reflection of reality. Instead, think of a model as a purposeful abstraction. It's an edited reality. It's the core underlying idea that a carefully written piece of code is actually trying to convey.
To put this into perspective, think about an 18th century Chinese map of the world. In these historical maps, China is typically placed right smack in the center, taking up almost the entire page, while the rest of the world's countries are just reduced to tiny, perfunctory dots around the edges. Now, is that a perfectly accurate geographical representation of the real world? Obviously not. But as Eric Evans points out, this was a model of the world that was entirely appropriate for an inward-facing society. They deliberately ignored all that extraneous foreign detail because, frankly, they just didn't care about it. Now, you couldn't use it for modern navigation, but for their specific time and purpose, it was a highly effective model.
Eric Evans actually captures this perfectly. He says, a model is a simplification. It is an interpretation of reality that abstracts the aspects relevant to solving the problem at hand and ignores extraneous detail. Just like that ancient map, our software models have to deliberately ignore the stuff that doesn't matter to our specific business problem. If you're building a routing system for cargo, you don't need to model the molecular structure of the cargo ship or what the captain's favorite color is. You simplify, you abstract, you literally just ignore the noise.
Actually, think of modeling a lot like movie making. Even a documentary film doesn't just show unedited, raw, real life. That would be excruciatingly boring to watch. A filmmaker selects very specific aspects of an experience, they edit out the mundane parts, and they string it together to tell a very specific story. As a domain modeler, you are doing the exact same thing. You're choosing a particular model strictly for its utility. You're editing out the messy, irrelevant business reality to build a system that works perfectly for what your users actually need.
So let's get our terms straight so we're all on exactly the same page here, starting with the domain itself. A domain is simply a sphere of knowledge, influence, or activity. Basically, this is the actual, real world of the business you're writing software for. It could be cargo shipping, high-frequency trading, maybe a complex manufacturing process. It's the messy, sometimes completely chaotic reality that the business experts live in every day. Next up, we have the model. A model is a system of abstractions that describes selected aspects of a domain to solve problems. Now, really emphasize that word selected here. A model is an artificial creation, and it's designed strictly for problem-solving utility. It's the tool we use to somehow grapple with the overwhelming, massive volume of information that exists out there in the domain. Now smash those two concepts together, and what do we get? The domain model. A domain model is a rigorously organized and selective abstraction of a domain expert's knowledge. It is not, and this is crucial, it's not just that chaotic jumble of knowledge floating around in a stakeholder's head. And hey, we've all been in those meetings. Now, a domain model is a consciously structured form of knowledge that makes sense of the chaos and focuses it directly on solving the problem at hand.
Okay, so now that we've hopefully shifted our mindset a bit, we need to talk about utility. Why do we even bother going through the agonizing effort of choosing one model over another? Well, in domain-driven design, there are three primary uses that dictate why we choose a specific model. Number one, it shapes the design. Number two, it becomes the backbone of the team's language. And number three, it distills knowledge. Let's dive into each of these.
First up, the model and the heart of the design shape each other. There absolutely has to be an intimate, binding link between your conceptual model and the actual running code. If your model is just some theoretical whiteboard exercise that doesn't actually map to your implementation, well, it's pretty much useless. And frankly, the correctness of your software is immediately going to be suspect.
When you're using model-driven design, the abstract concepts you discover in the domain translate directly into the software constructs.
the entities, the value objects, and the services that we're coding every single day. This binding is absolutely crucial because it ensures that all our careful upfront analysis actually makes it into the final product. Plus, it means that 6 months down the line, when we have to maintain the system, we can understand the code by understanding the model. The code literally is an expression of the model.
Moving on to the second use, the model becomes the backbone of a language used by everyone on the team. Because we've firmly bound the model to the implementation, developers and domain experts can finally talk to each other about the software using the exact same terms. That agonizing pain of constantly translating back and forth, gone. The language is based entirely, 100%, on the model.
And this brings us right to the concept of the ubiquitous language. On a typical project, it's a mess of translation. Developers translate for domain experts, the experts translate for developers even have to translate for each other. And translation just blunts communication. It muddles the concepts. But right there at the intersection of the technical and business teams sits this shared, ubiquitous language. It weaves the model directly into our daily development activity. When the business experts and developers are forced to use this shared language, you quickly uncover vagueness, you spot contradictions, and that leads to a massively stronger design.
The third core utility is that the model is distilled knowledge. Remember, a model is our agreed-upon way of structuring information. Just like we saw with the 18th century map, it's about intentionally dropping the concepts we don't need so we can focus relentlessly on what's essential. It's the pure essence of the domain, extracted into a form that makes it intensely valuable for the software we're trying to build.
As Evans puts it, a model captures how we choose to think about the domain as we select terms, break down concepts, and relate them. And this isn't just a passive one-off whiteboard session. That shared language empowers developers and domain experts to collaborate and literally wrestle chaotic, real-world information into this clean, distilled form. And because the model is tightly bound to the code, those early feedback loops, like during sprint work or pair programming, they force us to continuously evaluate and refine this knowledge.
So how on earth do we actually get to that perfectly distilled knowledge? Well, it happens through a process called knowledge crunching. This is the vital, highly collaborative team effort required to actually pull a clean model out of business chaos. Effective domain modelers will take a massive torrent of information. We're talking legacy systems, endless docs, hours of discussions with stakeholders, and they probe it for just the relevant trickle. It's a constant, shared cycle of learning. You try out an organizing idea, it doesn't quite work, you reject it. You try another one. Ultimately, you're panning for gold until you find that one set of abstract concepts that makes perfect sense of all the detail.
All right. As tech leads, as senior engineers, we need to have a really honest conversation here about framework complexity versus domain complexity. So often we get completely obsessed with the framework side. We'll spend weeks arguing about perfect database routing or the slickest new UI framework or how to isolate our architectural layers just right. Why? Because it's safe, it's predictable, it's heavily technical. But the real heart of the software, the actual reason the business is paying us to build this thing, that sits in the domain. Domain complexity is messy, it's incredibly difficult to understand, and shockingly, it's often totally ignored by otherwise brilliant technical teams. Which leaves us with one pretty provocative question to wrap up this explainer. Are you hiding behind your tech stack, or are you actually tackling the complex heart of your software? Domain-driven design demands that we stop treating the business domain as a secondary concern. We have to get in there, engage with the domain experts, crunch that knowledge, establish a ubiquitous language, and build a purposeful abstraction that sits at the very core of our code. Because honestly, that is the only way we can build software that truly serves its purpose. So chew on that the next time you fire up your IDE. Thanks so much for joining me for this explainer, and I'll see you in the next one.